All right, so yesterday we have seen how to use graph to interpret the motions of something and also how to sketch graph based on the motions of an object. All right, so just as a quick recap, so we're going to see what does it mean by increasing velocity, decreasing velocity, and then constant velocity, and also the velocity at the increased rate. So first, increasing velocity. Now, what does it mean by increasing velocity? Increasing velocity means there is a change in velocity between initial and final. So when you want to calculate the uh, the accelerations, you're just going to look at the initials and the final. Okay, you don't have to think what happens in between them. It could be increased at a constant rate or increased at a non-constant rate. So the examples given here from 0 until 6 seconds, the velocity increased by 30 meter per second. So in this case, we say the object accelerate. All right, accelerate means it's getting faster. And then decreasing velocity. Okay, decreasing velocity. So initially, your object is moving at 30 meter per second. After 6 seconds, it comes to rest. So when it comes to rest, this one we call deceleration. Decelerate means object slows down, right? It's from a faster rate and then it goes towards a slower rate, okay, or it is stopped eventually. So in this case, what are you going to get? You're going to get a negative acceleration. So negative acceleration, sometimes we call it decelerate. So if the questions give you, now you have an object that decelerate at a 5 meter per second square, then when you want to use it in your calculation, you need to add a negative sign. All right, so decelerate means it should be a negative value, negative acceleration. Okay, and then when your object is moving at constant velocity, now this is where students always got it wrong. Constant velocity doesn't mean constant acceleration. All right, constant velocity means zero acceleration. Zero acceleration, it can happen at two different situations. Okay, if a equals to 0 meter per second square, one possibility is moving at a constant v, and then another one is object is at rest. So at rest means your v equals to 0. So there are two possibilities, but students always thought that since a equals to 0, v must be equals to 0. No, that is not the case. It can have a constant velocity. Now, what does it mean by constant velocity? Constant velocity means that every second the object is moving at the same velocity. So for example, now you look at the diagram. Initially, your object is moving at 10 meter per second. After 2 seconds, still 10 meter per second. After 4 seconds, still the same. After 6 seconds, after 8 seconds. So from 0 until 8 seconds, the object keep moving at the same velocity. So in this case, we say constant velocity, or another terms we use is a uniform velocity. Okay, uniform velocity. So this is a third example. So next one, constant acceleration. Again, students always have misconception when they see the terms constant acceleration. They thought velocity should be constant. No, constant acceleration, it means your velocity is increasing, and it is increased at a constant rate. Okay, so that is the relationship between constant acceleration and velocity. So your velocity increase at constant rate. Now, what does it mean by increase at constant rate? You look at the example given. From 0 until 2 seconds, in this 2 seconds, it increased by 10. Another 2 seconds, it increased by another 10. Another 2 seconds, it increased by another 10. So that is the meaning the velocity increased at constant rate. Okay, so these four examples, they are the examples that is related to velocity. So you have to be able to imagine what is going on, okay, by looking at the given terms. So if the terms given is acceleration, accelerate, decelerate, no accelerations, or constant acceleration, they all carries different meaning. Okay, or if the question give you now your velocity increase at a constant rate, or it says you have an object that is moving with constant velocity, okay, especially this case is very important. Questions like to mention constant velocity, and they want you to understand that if you are given constant velocity, then it means a is equals to 0. Okay, question seldom tells you now your object has 0 acceleration. No, question will only tells you your object is now moving at constant velocity. then by default, you should know that A is equals to 0. So that is what we call hidden information. Okay. So another thing that is important is when you have a deceleration. So deceleration A must be negative. So you need to include the negative sign in your calculation. That one we'll discuss it in the next week lecture, in our next lecture. Okay. So today let's look at the graph. Okay, let's go back to the graph in your module. So exercise 1, okay, exercise 1, a bus travels along a straight road for 600 meter. Okay, it travels at a constant velocity for a whole journey, which takes a 90 second. What was the velocity of the bus? Okay, so what was the velocity of the bus? It's actually very simple. So you just look at the graph. Now it's a uniform graph, so it doesn't matter whether it's asking for a instantaneous velocity or average velocity. Straight away you can get the velocity because it's a uniform velocity. Okay, uniform graph, straight line graph. So now how are we going to calculate? So velocity, okay, velocity equals to change in displacement over the change in the time, which is then equals to 600 minus 0 over 90 minus 0, right? So the answer is 6.67 meter per second. So the velocity for this bus is 6.6 meter per second. So it's moving at a very, very slow rate.
Madam,
Yes?
kalau contoh saya tak buat yang zero tak apa ke?
Kalau untuk soalan ini tak buat zero tak apa. Sebab dia tak sebut initial, dia tak sebut final. Saya cuma ambil 2 titik. So kalau kamu nak terus guna 600 divide by 90, boleh juga, tak ada masalah.
Okay.
Okay, so kalau dalam exam kamu tak nak tunjuk zero, actually dia tak ada masalah besar. Kecuali dia ada case di mana yang initial dia bukan zero, then anda mesti tunjuk. Alright, now second questions. Figure shows the velocity time graph for a mop, which travels between two sets of traffic light on a straight road. Okay, what is the mop acceleration in each of the time interval? So now it asks you to split the graph into 3 zones. Zone 1, Zone 2, and Zone 3. Okay, or to be more precise, this is your OX zone, this is your XY zone, and then this is your YZ zone. Now, how do I know, if the questions didn't mention, how do I know when am I going to split it? So you look at the line, okay, the moment the line changes its direction or its shape, then you need to split it into a separate zone, okay, separate category. So for instance, the O until X is a straight line, and then when it reaches point X, the graph changes its direction. So this one, it means it is another set of calculation. Okay, so bila bentuk graph sudah berubah, bermaksud itu adalah zone yang berlainan. So itulah di mana kamu kena letak dotted line, okay, to indicate that you are going to calculate them separately. So from 0 until 6, you can use one equation. 6 until 18, you can use one equation. 18 until 21, you use one equation. All right, you cannot straight away calculate from 0 until 21, okay, with one equation. That is impossible. All right, the main reason why, that is because, okay, now the motions, the directions of motion changes, and now you are looking at vector. So when you're looking at vector, you need to take into consideration the directions, okay, and what happens to it. So what happens here, so from OY, okay, what happens in OY? Now OY, the object start to move. Okay, so when does it start to move? It start to move from O. So from O, it's moving towards positive direction. So how do I know it's moving towards positive direction? Because it's towards positive V. Okay, it's moving towards positive V. So moving towards positive direction with an increasing velocity, right? Increasing velocity until it reaches point X. Okay, so until it reaches point X. So this is what happens in the first section. So OX, okay, now this is A. So A with a subscript OX to indicate that now you are calculating the acceleration from O until X. So use subscript in your calculation. Subscript is very important. So it is equals to V final, which is your Vx minus your V initial, divide by Tx minus T initial. Right? So you minus it, and then what are you going to get? You're going to get 12 minus 0 over 6 minus 0, which is 2 meter per second squared. For the second part of the graph, okay, it is a straight line. Straight line means that there is no acceleration. So if there is no acceleration, now you don't even have to calculate it. All right, if you want to calculate it, also nothing wrong. Okay, basically it's just 12 minus 12 divided by 18 minus 6. Eventually you are going to get 0. Otherwise, you can just write 0 m as negative 2. So make sure to include the unit. All right, because without unit, it's considered as wrong. So AXY is equals to 0 because it's a horizontal line. Means that your object is moving with constant velocity. So constant velocity, like we discussed just now, it has 0 acceleration. All right, so from X until Y, done. Now, what happens from AY until AZ? So AYZ is equals to, now your V final, okay, your V final is now Z. So VZ minus Vy divided by Tz minus Ty. Okay, so that is equals to, now you look at the informations at point Z first. Don't take the wrong informations, otherwise you're going to get the wrong answer. All right, and you must use Z minus Y, because from Y until Z, your object decelerate. Okay, your object decelerate. So if it is decelerate, means that it must be a negative value. So initially it accelerate, and then moving with a constant velocity, and then it decelerate until it reaches point Z. So Z, you have a V equals to 0. So this 0 is a mass. So for AOX, if you just write 12 divided by 6, that is fine. But when it comes to AYZ, you must mention this 0, okay, because it represents your final velocity. So 0 minus 12 divided by 21 minus 18. So you're going to get a negative 4 ms negative 2. All right, so that is how you calculate it. Okay, that is how you calculate accelerations at each individual part. All right, so we are done with questions A. Let's look at questions B. Now, questions B, it asks you to calculate total distance. Okay, so this question, it doesn't matter whether the question is asking for total distance or total displacement. Okay, you're still going to get the same answer. So total distance, how are you going to calculate? So total distance is equals to area under the graph. All right. So in your exam, if you got right this, usually you got 1 marks already if you have a graph question. So same goes to questions A. Actually, questions A, if you got mentions, gradient equals to your acceleration, okay, then you can get 1 mark for the concept. It means you understand how to interpret the graph. Okay, which part of graph represents acceleration, which part of the graph represents area, distance, sorry. All right, so make sure you write down this. Okay, even though it seems like not that important, but then actually it gives you 1 marks in your exam because it represents the concept. You understand the concept. All right, so total distance equals to the area under the graph. So now this case we have a trapezium. Okay, this trapezium. So distance, you don't have to split it if they are all located on the same axis. So this is a positive axis. So straight away you can calculate it as a one shape, one object. So it is equals to 1 over 2. And then we have a 21 plus 12 times the height of the trapezium, which is another 12. All right, so the answer should be 198 meter. So how to obtain this 12? This 12, actually, I got it from 18 minus 6. All right, so to calculate trapezium, now this is our A. Okay, the bottom line is a A, the upper line is a B, and then this is the height. So equations for trapezium is equals to 1 over 2 a plus b times h. All right, this is something that you should have learned in your secondary school. So I'm just rewrite it as a part of revision. Okay, so you know how to calculate the area for trapezium. Now, sometimes in the exam, if you forgot how to calculate the area for trapezium, then what should you do? You can actually calculate as 2 triangles and then plus 1 rectangular. All right, you can use a area OX plus area XY plus area YZ. Also can, nothing wrong, okay, nothing wrongs. So you can calculate them as a 2 triangle plus a rectangular, or you can straight away apply the equations for trapeziums to get the areas under the graph. Okay, so I give you 1 minute to write it down, to write the information that you don't know, or maybe you have already forgotten. All right, and then we are going to proceed to the next question. So 1 minute for you to write down the important information. So if you have any questions, you may ask. All right, next. Okay, next. A toy train moved slowly along a straight track according to a displacement as again t graph in a figure below. So now this is a typical exam questions where it asks you to transform the graph, okay, from a ST graph to a VT graph. So it asks you to change it. Okay, how to convert it from a ST graph to VT graph? Now, first thing, you have the values in the graph. Okay, if no value, then you don't have to calculate it. But now you are given the values, then you have to calculate the velocity at every single position. So how am I going to do it? I'm going to give it a name first. Let's say I'm going to give it a section 1, section 2, and then a section 3. All right. So next, I'm going to calculate its velocity at every single section. So V1 is equals to, again, now you are given an ST graph. So ST graph, okay, then the gradient is equals to the velocity. Okay, so you want to calculate the gradients of every single section. So V1, the gradient is 4 minus 0 divided by 6 minus 0. Okay, which is then equals to 0.68 ms negative 1. V for section 2. Now this horizontal line, it tells you that your object now is stopped at a displacement 4 cm. It is not moving for 4 seconds. So this one is 0 ms negative 2. All right. And then for a sections number 3, V3. Okay, I made a mistake here. It should be cm negative 1, cms negative 1, because the unit is cm. Okay, cm and s. So a V3, now I have the sections. So the V is, Okay, 10 minus 4. So 10 minus 4 divided by 14 minus 10. Okay, which is then equals to 1.5 cm as negative 1. All right, so we are done with the value. What are we going to do next? So next thing, we want to sketch a graph. Okay, now you have all positive value, so you just need a positive axis. Okay, you don't need to draw the negative axis. Then I have here V, cm as negative 1. And then my x-axis, t as negative 1. And then this is a 0. So from here, I have a 2 second, 4 second, 6, 8, 10. And then I have 12. I have a 14. Right? I have a 14 here. And then what am I going to do next? Next, I'm going to sketch the graph, okay, before I label the y-axis to make it easier for me. Okay, now how am I going to sketch the graph? You look at V1. V1 is occurring from 0 until 6. So this is a 6. Okay, so this is where we want to sketch the graph. All right, and now we have a 0.68. Now, this is a linear graph, okay, a straight line graph, which indicate that now my object is moving with uniform velocity. Uniform velocity means it is a horizontal line. So horizontal line, okay, horizontal line. And then when it reaches 6, you just put a dotted line down. Okay, put a dotted line. So here you can then label as 0.68. All right, so for y-axis, to make it easier, you don't have to do the scale. You just label 0.68. And then for sections 2, from 6 until 10 seconds, your object is not moving. Therefore, you have 0 velocity. So 0 velocity, you draw a horizontal line along the x-axis, right? And then for third section, which is from 10 seconds until 14 seconds, object is moving at 1.5. So you make a dotted line, and then this one should be located at a place that is higher than your 0.68. Okay, so let's say somewhere here. Okay, and then you draw a dotted line down. All right, so this is your 1.5. Okay, this is your 1.5. So the graph, you have 3 solid line, which represents the velocity, okay, the uniform velocity at 3 different stage. Okay, at 3 different stage. Now some
Madam,
books they put a some books they put a vertical line as a solid line. So I think that should be fine. Okay, ada buku dia letak garis lurus yang menegak ini sebagai dotted line, tak ada masalah juga. Okay, kalau kamu nak letak solid. Yes.
tak apa, Madam dah jawab dah.
Okay, memang ada buku dia terus letak solid. Boleh juga, okay, that's fine. Alright, that is fine. So if you want to put a solid line, also can. So that is how you draw the graph. Okay, that is how you draw the graph. Okay, you transform from one to another. All right. Now, how to calculate the marks in this question? So this question now, because it needs you to calculate the values 0.68, 0, and 1.5. So usually all this calculation, it worth 1 marks in an exam. All right. And then you label the graph correctly. Okay, you label with a correct axis, with a correct unit, correct axis, correct unit. This is another 1 mark. Okay. And then you got the correct shape. Okay, the correct shape. So shape is another 1 mark. So usually one graph, it worth 3 marks. Okay, it worth 3 marks. Now some graph is a 2 marks. Okay, some yeah. Saatnya dia tiba-tiba sendiri gerak. Alright. Alright, now sometimes dia gila dah. Okay. Okay, now sometimes one questions it worth 3 marks, sometimes it worth 2 marks. Okay, 2 marks usually is the types of the graph that doesn't require you to calculate the value. Okay, you just need to sketch the graph with a correct x and y axis, the label, and then with the shape. So for the graph that needs you to calculate the y-axis or maybe the x-axis, then it will have an additional marks. So this question usually it worth 3 marks in your exam. All right, and this is the typical exam questions. All right, next, calculate, okay, determines the average velocity for the whole journey. Now, it says whole journey, so you don't have to look at it part by part, okay, because when it comes to average velocity, what is important is actually it's a final and also it's initial. All right, so V average for whole journey is your your S final. Okay, your S final minus S initial divided by T final minus T initial. So whole journey, let's go back to the graph. Now, whole journey, the graph is stopped at 10 cm, and then at the times T equals to 14. So 10 minus 0 over 14 minus 0. Okay, because it starts from 0. Both X and Y axis start from 0. So the answer is 0.714 cm as negative 1. All right, 0.714 cm as negative 1. Okay, now calculate the instantaneous velocity at times t equals to 12 seconds. So at times t equals to 12 seconds, okay, we don't have enough information to calculate the instantaneous velocity. But what we do have, okay, at times t equals to a 12 second, we know that this line, okay, along this slope, object is moving with uniform velocity. Okay, so if object is moving with uniform velocity, right, so what is the information that we have? Uniform velocity, it is equals to your v average and also equals to your v instantaneous, right? Because we don't know where is the object when it is located, when the time is equals to 12 seconds. We don't have the enough informations. Okay, we cannot calculate the ds over dt because we are not given the equation. But what we can do is we can calculate the average velocity, because when the object is moving with a uniform velocity along a straight line from t equals to 0 until t equals to 14, at this part along this line, your v average is equals to v instantaneous, right? So we can calculate the average velocity for this slope. So we have a final, which is 10 minus 4, 14 minus 10. Okay, 10 minus 4, 14 minus 10. So v instantaneous is equals to 10 minus 4 and then 14 minus 10, which is then equals to 1.5 cm as negative 1. Right, 1.5 cm as negative 1. So this is how you calculate the instantaneous acceleration. Instantaneous velocity. Okay, so it should be v. So v average, v instantaneous. All right. So that is how you calculate it. So once you got the answer, then that is done. That is our questions number 3. Right? So I repeat again. How do I know that V average is equals to V instantaneous? Because your object is moving with uniform velocity. So how do I know that it is moving with a uniform velocity? Because along this line, it's moving in a straight line. Okay, it's a straight line. So if it is a straight line graph, means that the velocity is uniform. So if the velocity is uniform, then we can conclude VAV equals to V instantaneous, and therefore you can calculate V instantaneous by using V average. All right. So done. So again, I give you a, okay, I give you 1 minute to write down the important informations. All right. So after 1 minute, we'll continue. Okay. So make sure you have the things that you need to label. Okay, you know what is the things that you must label, and then what is the important point, how to score in the exam. Okay, so far any questions before we proceed to next more complicated questions? Tak ada, semua yakin. So tiba-tiba kalau exam pun boleh jawab dah kan? Hey. Okay, so now these questions, I give you 5 minutes. I want you to try it first. Okay, how to change it from VT graph to AT graph. Okay, I want you to change it from VT to AT. So kamu cuba buat dulu. Okay, you try first. So the way to solve it is exactly same as what I did just now. Okay, you try to see what types of graph it is. It is a V against T graph. So when you have a V against T graph, remember gradient represent acceleration. So this is the things that you have to keep remind yourself. All right, and then area under the graph represent distance. Okay, so I give you 5 minutes to sketch the graph. See whether you can get a correct graph or not. Okay. So now let's see whether you got the correct answer. Okay. Wait, yeah. All right, this is the answer. Okay, so you calculate the accelerations at every part. All right, now if I put it, where can I put it? Okay, I put it here. So if you calculate the accelerations at every single point, you will see that from 0 until 5 seconds, you have a positive acceleration, positive 0.4 meter per second square. So make sure you have the correct label. Okay. Oh, okay, now make sure you have a correct label AMS negative 2, and then you have a TS along the x-axis. And then for the second part, okay, you have a 5 until 15, okay, which is also a positive accelerations, but now because it's less steep, okay, you look at the original graph, the uniform velocity is less steep, okay, so therefore you have a, yeah, let me move it a bit. Doesn't want to move. Never mind. All right. Okay, so now it's a less steep from a 5 to 10. As you can see here, less steep means that the acceleration actually is decreasing. Okay, but it's still moving with a positive acceleration because it's still moving towards a positive direction. Okay, so just that is decrease its velocity. All right, so it becomes it's increased as a slower rate. Okay, it doesn't mean that it's decreased its velocity. The velocity still keep increasing, but increase at a slower rate. Okay, less steep means now it increased at a slower rate. So therefore you have a smaller acceleration. All right. So based on the graph, it's actually very simple. From 0 to 5 seconds, it increased as a very fast rate, and then it slows down a bit, increase at a slower rate. So from 15 to 20 now is a horizontal line. Horizontal line, remember, it doesn't mean that the object is not moving. It just means that the object is moving with constant velocity. Okay, constant velocity. So constant velocity, zero acceleration. And then next, now, while your object still moving towards positive direction, okay, so this is the motions of a leaf. So this part, actually, it means your leaf still moving upwards. Okay, it's still going up, even though now you have a line, you have a graph that seems like it's going down. Okay, but that is not the case. I know it is still going up. Why? Because I still have positive V. All right, just that now it's a slowing down. Okay, it decreased its velocity from 4 until 0. It's slowing down, but it's still going upwards. Okay, it's going upwards. So it's slowing down means that now at this part, the object decelerate. So it's moving with positive V, but then now you have a negative A because it's decelerate. All right, it decelerate. And then from a 25 until 30, now the leaf is stopped again. Okay, now this horizontal line, because it's equals to 0, so it means your object is at rest. So this is how you interpret graph. Okay, this is how you interpret the graph. So constant V and then upwards, okay, but a decelerate and then at rest. So at rest, again, we have a equals to 0. Okay, we have A equals to 0. And then what happened next? Now, this one, your object is moving with increasing velocity. Okay, increasing velocity. Just that now your object is heading towards negative direction. All right, increasing velocity towards negative direction. So how do I know? Because the value is increasing from 0 until 4, But because of this negative sign, okay, this negative sign, it indicates now your object is moving downwards. Okay, downwards. So just now going up because of positive, now it's going down because of this negative. So increasing velocity towards negative direction, so you have a negative A here. All right, you have a negative A here. And then from 35 until 40, again, is a horizontal line. Therefore, again, your A is equal to 0 because your object is moving with constant velocity. So again, this is constant velocity now. It's not at rest. All right, it is constant velocity because you have a non-zero velocity. And then at last, this part, okay, the last part, your object is moving with decelerate, okay, decreasing velocity. Okay, decreasing velocity. And then because it is still moving downwards, okay, it's a negative direction. Therefore, you have a negative A. Wait, negative A. Yeah, negative A now. Okay, decreasing. Wait, yeah, let me see. I think something is wrong in the calculations. So you have a 0 minus negative 4 divided by 50 minus 40. Now, the last one should be positive line. Okay, the last one should be positive line because it's 4 over 10. Okay, so there's a mistake in the answer. So this one should be positive. So negative become positive. So it's a positive 0.4. So it should be somewhere here. All right, it should be somewhere here. So the last one is wrong. All right, don't lose like the last one. So the last part is a positive because it's moving with decreasing velocity towards negative direction. So don't follow the answer scheme given. All right, so it should be a positive graph. So the last 0.4 should be positive. Yeah, take notes, especially those of you who have already get the answer from the other class video. All right, so make sure you correct it. So this should be positive. Okay, so how do I know it's positive? Now, in exam, actually, what do you have to do? You don't have to memorize motion. Straight away, you just calculate its gradient. All right, you calculate its gradient like what I did just now. So how do I know the last part is positive? Because I take here as a final position. Okay, this is a final position. And then this is the initial position. Then I calculate its gradient. So 50, now at times t equals to 50, I have 0 velocity. So 0 minus negative 4. Okay, 0 minus negative 4 divided by 50 minus 40. So I should obtain a positive A. And then how do I know this is a negative A? Now let's look at one more example. So from a 30 until 35. So this is initial, this is final. So final, I have negative 4. Negative 4 minus, okay, initial is a 0. So divided by 35 second minus 30 second. So it gives me a negative value, okay, negative 0.8. So that is how we determine whether it is positive or negative based on the graph, all right, based on the graph. And this is the motions of a leaf. So you should know that whether it's going up or going down, all right. So I give you 1 minute to write down the graph, okay, to correct your graph if you got it wrong. And also to write down how do you obtain the positive and the negative sign. So I give you 2 examples. The rest you try to complete it. If you have any questions, then you may ask before I proceed to the next part. All right, so this is the first part of this question. Okay, so next, calculate the average acceleration. So once again, you have average acceleration. Now, when it mentions average, actually it's very simple. You just look at the initial and final. So this is your initial. Okay, initial. And then this is your final. So initial, what is the velocity, and final, what is the velocity? Now let's look at the graph. 20 and 40. 20, I have v equals to 4. 40, I have v equals to -4. Okay, so -4 and 4. -4 and 4. So A average is equals to, all right, is equals to what? Is equals to your final, which is -4, minus initial, which is a +4. So -4, +4, -4 minus +4. So divided by the time, 40 minus 20. So obviously you're going to get a negative value here, which is negative 0.4 ms -2, right? So remember, -4, you have to keep the negative sign. So minus a +4. So -4 minus +4 give you a negative sign, divided by 40 minus 20. So that is the answer for questions B. Okay, so that's it in your handout, in your module. What I want you to do, I want you to add 2 questions. Okay, I want you to add 2 questions based on this graph. Okay, which is, I want you to calculate total distance traveled by the lift. Okay. Total distance traveled. This is your question C. And then questions D. Total displacement travel. Aha. So how are you going to calculate distance and a displacement based on the given graph? Try to think. All right, I give you 3 minutes to think. How are you going to calculate distance travel? How are you going to calculate displacement travel based on the diagram given? Try to imagine, try to recall. Now, this is the motions of a lift. And then what is the definitions of a distance? What is the definitions of displacement? Think about it. All right, 3 minutes for you to answer this question. Okay, for you to think. How are you going to solve it? All right, you don't have to write out the complete answer. Just think, how are you going to solve it? If you got the answer already, you got the idea on how to calculate it, you may post in the chat and I will tell you whether it's correct or wrong. All right, so cuba fikir, macam mana kamu nak kira total distance travel by the lift? Macam mana kamu nak kira total displacement travel by the lift? Kalau kamu dah ada idea macam mana nak jawab soalan ini, kamu tulis dalam chat. Okay, so try to recall definitions for distance and the definitions of displacement. All right, seems like you guys understand the graph very well. Okay, three of you actually got the correct answer. So distance is the total area under the graph, okay, regardless of whether it is a positive or a negative area. But when it comes to displacement, then you have to use a positive area minus the negative area. You find the difference between two areas. Okay, so when it comes to these questions, you have to split it into two parts. So this one, I'm going to call it area A. Okay, so area A is the first one. Okay, it's a positive area. And then your area B, okay, this is your area B. So area B is the negative area. So distance means the total path traveled, if you recall the definition, right? This is a total path traveled. And then displacement is the distance, shortest distance. Okay, shortest distance between initial and final. So now you have a graph like this, okay? You have a graph as shown in the diagram. So area A, it represents what? It represents your object is moving upwards. So for area A, your object is going up, okay? Your object is going up from A. So this would be your area, the distance traveled going up, okay? The distance traveled upwards. And then for area B, what happens here is, now your object is moving down, okay? It stopped from 25 until 30, it stopped for 5 seconds, and then it's moving downwards. This is your area B. So if you add the area together, then you're going to get distance. So area A, okay, area A plus B equals to distance. And then the difference between initial point and final point. So this one is your displacement. So displacement, this is your A minus B equals to your displacement. All right, equals to your displacement. So your lift going up and then going down again. Okay, going up until 25 seconds, stop for 5 seconds, and then it goes down. Therefore, you have two different areas. One is above positive X, one is below positive X axis. Okay, so displacement pun under graph cuma nanti ada yang positif dan negatif. Okay, displacement kurang berbanding. Ya. Okay, displacement pun ada positif dengan ada negatif. So kalau ada negatif, kamu kena tolak dia punya negatif. So the negative area is your B. The positive area is A. Alright, so one going up, one going down. So from A, you go up. So you calculate the area that is going up, and then you minus the area that is going down. Sometimes B might be more than A. So what does it mean? It just means that your object is now located below its original position. All right, so that one we'll keep it for a lecture. All right, so most probably we're going to have a lecture tomorrow where I'm going to explain how to use all these sign conventions in your calculations. So I think that marks the end of today's class. You calculate C and D by yourself. The reasons why I add these two questions, because I want you to know what is the main difference in distance and displacement when it comes to graph. Okay, so any more questions? Lecture waktu bila? Lecture saya tengah fikir nak buat jam 11 supaya kamu boleh bangun dan boleh sempat makan lunch. Jam 11 kamu rasa okey tak? Ada apa kelas lain tak?
Okey, madam. Ada kelas.
Okey je.
So
Okey je,
kamu
madam.
boleh tidur
Okey je,
sampai
madam.
otomatik bangun.
Ya.
Sampai ke sebelah tak apa, madam. Okey.
Okay, so if no questions, I think that's all for today.